Good afternoon, class. Today we will be talking about inequalities in two different triangles and what we call an indirect proof. This is section 6 of chapter 5. The first thing that I need to talk about is something we call a hinge theorem. Now, the reason we call it a hinge is sort of like a door hinge, if you so wish to think of it that way. What we have here is we have two sides of one triangle matching up perfectly to two sides of another triangle. However, their included angle is different. So, if I would have a picture like this, I can see that those two angles are clearly different. But I have my two sides match up to the two sides over there. This means because this angle here is larger, this side is longer than its corresponding one in this triangle. So these inequalities, we will be comparing between two triangles. In this case, if I see something like this, where I have this length match up to this length match up to this length, and I know that this angle A is smaller than angle D, then I know this side across D has to be larger because it has longer because it has a larger angle. So length of segment EF is a bigger number than length of segment BC right here. That's all this theorem says. If two sides match up, two sides of one triangle are congruent to two sides of another triangle, and the included angle is different, then the sides across from that included angle match up in the same way. If angle D is larger than angle A, then segment EF is longer than segment BC. The opposite is also true. If I have two sides in a triangle match up to two sides in a triangle, and I know that the third side is longer, such as is the case in this picture. 10 is larger than 9. Well, that means the angle across from here, angle D, has to be larger than angle A, period. The side across is longer, and the other two sides match up. Though the only thing that's changed is the angle measure. And I know that angle D has to be larger than angle A, period. Alright, so in this example 1, determine which is larger. Well, on the left side here, I look. Side matches up to side matches up to side, so I have two sides matching up to two sides of a triangle. I notice that angle A is larger than angle D, which means, correspondingly, that segment BC has to be longer than segment EF. So I look here. That means BC is a larger number. And if I'm thinking of which sign to use here, I'm going to use a less than sign because the arrow goes like this. Because the arrow goes like this. You could think of it, the alligator's eating the larger number. So there, this segment is smaller than that segment because angle D is smaller than angle A. So that's the sign I would use. If I try over here, the two sides match up. Now, yeah, they're flipped around a little bit. However, I don't care about that. Two sides match up to two sides. The third side, there's a difference. So I know that in the included angle D and A, there also has to be a difference. Well, 6 is larger than 5. So in this case, this side EF is longer than side BC. So that means the angle across from side EF has to be larger than the angle across from side BC. So angle D has to be larger than angle A. So what I'm going to write down here is a greater than sign as such. And again, greater than, the larger number always has the alligator trying to eat it. So in this case, measure of angle D is a larger number. So this is the symbol I'll make. And that's all I'm asking here. Look at the triangle, find out where they match up. A bigger angle means a bigger side. Now comes time for the tougher part, indirect reasoning. This reasoning's a little bit tougher because it's not direct. We kind of take the long way around, so to say. It involves us making a temporary assumption that our desired result is false. in the example I came up with here is I'm trying to prove that all even numbers are divisible by 2, which that is true. Well, if I'm trying to prove this and I'm stuck, sometimes I'll try to come up with an indirect reasoning, and I'm going to assume that the assumption is false. Sorry, the conclusion is false. So in this case, I would make a temporary assumption that at least one even number is not divisible by 2. If I could prove that this here is false, it'd be the same as proving that this here is true. So, indirect reasoning involves making a temporary assumption that the desired result is false, and then showing that my assumption causes a contradiction. And that contradiction means that my original assumption was false, and that my desired result is true. So before we actually go into proving with indirect reasoning, let's just try practicing the making the temporary assumption. So in this case, write a temporary assumption you can make to prove the conclusion indirectly. So what we're going to try and do is make a temporary assumption that our conclusion is false. So if x and y are even, then x times y is even. The temporary assumption I'm going to make is that x times y is odd. Although I guess probably x times y is not even would be better. But I'm going to assume that this is true. And I'm still going to keep my hypothesis true. And this being true, x plus y being even, and then x times y not being even, well, if my hypothesis and my conclusion were both true here, that means my hypothesis and my false assumption will have a contradiction show up. So, number 2 here. If x times y is not 0, then x and y are both not 0. This might be hard to prove, because I'd have to prove every single number is any two numbers I use here, multiply, it's not 0. However, it might be easier for me to do a temporary assumption here. What if I assumed that instead of both are not 0, what if I said, there we go, x or y is 0. All it has to do is be one or the other. It could be both, but x or y could be 0. Well, that would actually be pretty straightforward to show. If x or y is 0, then if x is 0, xy is 0. Contradiction. If y is 0, xy is 0. Contradiction. This would be able to be proven true because I run into a contradiction by assuming my conclusion is false. Alright. And this last one here, if measure of angle A is larger than measure of angle D, then length of segment BC is larger than segment EF. What is my temporary assumption here? Well, it's just this last part. Either length of segment BC is equal to length of segment EF, or length of segment BC is less than length of segment EF. So, that's the possible conclusion I would make. Length of segment BC is less than or equal to length of segment EF. I would still leave this first part true over here on the left side, but I would make this right side less than or equal to. So, this is just us practicing making a temporary assumption so that way we can try and show that the conclusion is true indirectly. It's going to be a proof by contradiction. Concept 21, an indirect proof. You first have to identify the statement we're trying to prove. If, then, or given and prove. And now you're going to take your then or your proof step, and you're going to assume temporarily that this statement is false by assuming that its opposite is true. You'll reason normally from that point on until you reach a contradiction. And once you reach that contradiction, you will point out that the desired conclusion must be true because the contradiction proves the assumption false. And if its opposite is false, then the original has to be true. That's kind of our reasoning here. Alright, so let's actually try a proof using indirect proof. In example 3 here, write an indirect proof of theorem 5.11. Theorem 5.11. Oh yeah. If angle B here is larger than angle C, then it follows that this side AC has to be larger than side AB. Oh, indirect proof. This is a statement. If measure of angle B is larger than measure of angle C, then length of segment AC is larger than length of segment AB. My temporary assumption I'm going to break into two parts. The first part, what if I had length of segment AC be less than length of segment AB? So in case 1, I'm assuming this is true. Well, if this is true, then I would have measure of angle B being less than measure of angle C by theorem 5.10. If this side is shorter than this side, or I should point at this picture over here, if the right side over here is shorter than the left side, then my angle B has to be smaller than angle C. Whoa. My given was that angle B was larger. It can't both be smaller and larger than angle C. That's impossible. Contradicts. So this contradicts the given, and therefore AC being smaller than AB has to be false. It just has to be. It contradicts my given otherwise. Alright. But Mr. H, isn't less than the opposite of greater than? Well, sort of. You miss one small point, and it's really important to make. The opposite of greater than is less than or equal to. And that's where the second case comes in. What if I assume that the length of segment AC equals length of segment AB? Well, if I assume this, these two lengths are the same. It's now isosceles. Hold on a second. If it's isosceles, then angle B and angle C have to be congruent by the base angles theorem. Whoa. They can't both be congruent and having one of the angles be larger than the other. That's impossible. That contradicts the given again, and therefore this statement has to be false. A contradiction comes about by assuming the opposite is true. Therefore, my original proof had to be true. Because if I assume the opposite, I run into a contradiction. So therefore, my original had to be true, otherwise I contradict myself. This is all for chapter 5. Indirect proofs are by far the toughest. We won't do many of these, but they are kind of neat to do. We do this all the time, in fact. And in most cases this works. You just got to be a little bit more careful with this one, that you include everything in the opposite. Like in this example here, if I forgot the equal to case, I haven't proved it, because what if in case 2 here, this ended up working? And if it did, well then my case here wouldn't have been true because I didn't assume the opposite. There was actually something that ended up being true. That is all I have for today. Till next time.